Okay, now we're going to look at the second of our three valuation methods. This one is called the corporate value model, sometimes also called the free cash flow method. And the idea here is that we are going to value the entire firm first. So we're going to think about how much the entire company is worth, and that's actually going to be equal to the present value of the future free cash flows that the firm is going to produce. We've discussed the concept of free cash flows before. It's basically the operating income minus the net capital expenditures. And another way that we could think of it is that it's the cash flow from the company's operations in any given year that is actually available to be distributed to investors. That is, it's not needed for capital investment. All right, we're not going to go back into how to actually compute free cash flows. We're going to assume that you have that concept down and that you could compute it if you needed to. But we are going to talk about, once we have an idea about the free cash flows, once we have an estimate, then what do we do with them to eventually value the entire company, and then from there put a price on the stock. Okay, so to apply the corporate value model, what we're going to do first is to find the market value of the whole firm. So you might even call this the intrinsic value of the entire company. It's what it is actually worth, and the way we do that is to estimate the future free cash flows and find their present values. We'll demonstrate some examples of that here very shortly. Then, once we know how much the firm is worth, that's the hard part. The rest is actually very easy. We subtract off anything that the company owes, and we also subtract off the value of any preferred stock outstanding. Once we take those out, any value that is remaining must belong to common shareholders. So anything left over at that point is common equity, and so we simply divide the market value of all the common stock, the common equity, by the number of shares outstanding, and that will tell us what the intrinsic value of the stock will be, what the stock price really should be in equilibrium. Okay, the hardest part of that whole process is the first step, which is finding the market value of the entire firm by getting the present value of the future free cash flows. After that, you just subtract off any debt and preferred stock, and then divide what's left by the number of shares outstanding. Okay, some issues about the corporate value model. One is that it is often a preferred method for valuation. Especially when you're looking at a firm that either doesn't pay dividends or it has a dividend stream that is kind of hard to forecast. And that actually arises in quite a few cases, really. A whole lot of companies out there that you might be interested in valuing or investing in, they don't pay dividends. Or you may have the other problem of just having a dividend stream that is hard to forecast. Whereas maybe forecasting the future free cash flows is not necessarily easy, but not as hard, right? It's not quite as problematic as it might be to forecast the dividends. And in fact, this is often the preferred method for a lot of Wall Street security analysts. So the pros do sort of take this approach. There are some similarities to the dividend growth model. As you will see when you start doing the math. In the dividend growth model, we assume that the dividends either grow at a constant rate the whole time, or that at some point they settle down and eventually go to a constant growth rate. In the free cash flow model, we do a very similar thing. We assume that the company's free cash flows will either grow at a constant rate, or that they will eventually settle down and grow at a constant rate. There is a point if there is a non-constant growth period, there is a point where eventually it becomes constant, and the value of the firm at that point, we call it terminal value sometimes, although I don't really like that term all that much because it kind of suggests that's the end of the firm's life or whatever, which is not the case at all. It's just the end of the non-constant growth period, but that term does exist. It's probably good to be aware of it. Okay, so we do have an example here, but this one on the screen is a little bit more complicated. So what I'd like to do first is actually a simpler example from your homework. So we're going to go ahead and get that up here. And here's the problem. Okay, Smith Technologies is expected to generate $150 million in free cash flow next year. And the free cash flow is expected to grow at 5% per year indefinitely. So it's a constant rate of 5% per year forever. Smith has no debt or preferred stock, and its weighted average cost of capital, WACC, is 10%. If Smith has 50 million shares of stock outstanding, what is the value per share? There is one term in there that I probably should try to clarify for you, and that's the weighted average cost of capital, WACC. So what is that? We really haven't discussed that very much yet. Here's the idea behind weighted average cost of capital. A company has different kinds of investors. It has stockholders, it has lenders, so that would be creditors, some of those might be called bondholders, and it also may have preferred stockholders. Each type of investor, whether it be a debt holder, an equity holder, or preferred stockholder, is going to have a different rate of return that they expect and that they require to be fairly compensated for the risk that they are taking. The WACC, weighted average cost of capital, attempts to capture all of that information. So we consider the fact that we do have different classes of security holders, different kinds of investors in the firm, stockholders, bondholders, and preferred shareholders, and that all of them expect a different rate of return. So we consider all of that together and basically take a weighted average, and it's according to how much of the funds come from each source. And that tells us, for example, like in this case, we've got 10%. That tells us that all of our investors collectively require a 10% rate of return from us. And since the free cash flows are available to be distributed to investors as a group, then that is the appropriate discount rate that we would use for those cash flows. That's what we'll use. That is the 10% when we go and compute present values of those free cash flows. Okay, so we actually need to do that now. Remember that step one is to try and compute the value of the entire firm. We have a constant growth scenario here, which makes it a little easier. Remember when we had the constant growth for dividends, right? And we were trying to value the stock by just taking the present value of future dividends. How did we do that? Well, the present value of all of that, and therefore the price of the stock, was D1 divided by RS minus G. Okay, so what we had there, D1 was the next cash flow in the stream. So it was cash flow number 1 on that timeline if you wanted to plot it out. RS was the required return on those cash flows, and then G was the growth rate in the cash flows. Well, here we're not, in the first step anyway, we're not trying to compute the value of the stock. We're trying to compute the value of the entire firm. But the principle is the same. We're trying to find the present value of a stream of free cash flows. It is still a stream of cash flows. We are still finding the present value of an infinite stream of cash flows that are growing at a constant rate. So the first term in the formula for this case is just going to be free cash flow number 1, whatever that happens to be. We'll plug that in just a minute. The next term, instead of the required return on a stock, we're going to be using the weighted average cost of capital, because that's the required return on all of the cash flows collectively that the company produces. And then we're going to subtract off the growth rate, except this time that growth rate G is not a growth rate in dividends, it is a growth rate in free cash flows. So let's go ahead and apply that to this particular problem. The problem says, let's take a look again, that we're expecting $150 million in free cash flow next year. So free cash flow 1 is $150 million. We have a WACC of 10%. We have a constant growth rate in the cash flows of 5%. So plugging all that information in, 150 million divided by it's a 10% WACC minus a 5% growth rate. And so of course that's 150 million divided by the difference of 5% or 0.05, and that is going to give us 3,000 million. Now I know that 3,000 million is the same thing as 3 billion, but I'm going to go ahead and leave it in this form, expressing it in millions for right now, because it's actually going to make the next step of the problem a little bit easier. So that's the value of the company. It's $3,000 million, or 3 billion if you want to say it that way. That's the value of the entire company. That's actually the hard part. And this is step 1 in the process. So what's the second step in the process? Now that we know how much the entire firm is worth, the market value of the equity is going to be the value of the firm minus what? Well, it's going to be minus any debt and preferred stock. Okay? But how much debt and preferred stock was there? If you read the problem carefully, it says that Smith has no debt or preferred stock. Okay, so therefore this part is actually going to be 0. And so the market value of the equity is just going to be the 3,000 million, because we don't have anything to subtract off. I do want to emphasize that you very well could end up with something to subtract off here if I gave you that in a problem. So you might encounter a quiz problem or an exam problem perhaps, where in fact there is some debt and preferred stock that you need to subtract off. And in that case, I definitely expect you to be able to do that at this step. It's just that in this particular case, the amount we subtracted off was 0. In another case, it might not be. If you need to subtract anything off, then just do it. And then whatever you get as the result, that's what we're going to use in the next step. And the next step is the price per share, which you can write that as P0, is going to be the market value of the equity divided by the number of shares outstanding. So that's going to be the 3,000 million. And how many shares did it say were outstanding? 50 million shares of stock outstanding. And so when you divide, the millions actually cancel out here, which is why I kept it in that format. So you end up with just $3,000 divided by 50. So that is $60 per share. $60 per share is the price of this stock. Alright, so that's a good example of how to apply this particular method. I do want to go back and show you a more complex example here, this one involving non-constant growth. So this is a separate example where in the first year we're expecting, and these numbers are in millions, we're expecting free cash flow of negative 5 million, in year 2 positive 10 million, in year 3 positive 20 million. So there's no certain percentage growth rate in that set of cash flows. These are just the estimates, okay? And they're given. And then after that, the long run growth rate in the cash flows is expected to be 6%. So we could go ahead and forecast the next one, kind of like we did in the non-constant dividend growth example. I always like to forecast one more. So I take 20 times 1.06, giving me 21.20. And that'll help me in just a minute. All right, we are also told in this example that the WACC, weighted average cost of capital, is 10%. So we'll take each one of these cash flows, the negatives and the positives alike, and find their present values. So the first one we divide by 1.10 to the first power. That's because it's a 10% required return on the cash flows, and this is 1 year out. Divide this one by 1.10 squared, and divide this by 1.10 to the third power. All right, and so what you see over here, these first three numbers on the left side, are the present values of those first three expected cash flows. Then we go over here and we say, all right, at the end of the third year, we're entering a constant growth era. At the end of the third year, we reach a point where everything after that is going to be constant growth. So we can value the firm using a constant growth type formula at this point. So the next cash flow is 20, and we divide by the required return, which is the WACC of 10%, minus the 6% long-term growth rate. So you'd have 21.2 divided by the difference down here would be 0.04, and that would be 530. And again, these numbers are in millions, just to keep that in mind. So 530, and that's what you could sell the entire firm for at the end of year 3. So we need to find the present value of that, right? Because you couldn't actually get that until year 3. And so we would need to divide by 1.10 to the third. Okay, the 0.10 represents the 10% weighted average cost of capital, and then the third power represents the fact that this would happen at the third year. It's not the fourth year. It is the third year immediately after this free cash flow. That's what you could sell the company for. So having found the present value of that, we add them all up and we get about $417 million is the value of the entire firm. That's the hard part. The next two steps are pretty easy. It says here, if the firm has $40 million in debt and 10 million shares of stock, what is the intrinsic value per share? In other words, what's it really worth? The first step would be to subtract off any debt that the company has and any preferred stock. That wasn't mentioned here, but it would certainly be subtracted off right along with the debt if it were. So we take approximately 417 million minus 40 million, leaving us with about 377 million, and that is the market value of the equity. So that's the entire value that basically belongs to shareholders if our calculations are correct. And that would be your value if you owned all 10 million shares. So what's one share worth? Well, to get the value of one share, you need to divide by the 10 million. So we've got about 377 million divided by 10 million shares, and that gives us a final result of $37.69 per share. And like before, the millions, they aren't listed here, but they do cancel each other out, kind of like in the homework example.